Okay, Algebra 2, Lesson 51. This is the day you've been waiting for. We finally are getting to imaginary numbers after all these years. You get to see what imaginary numbers are. This lesson has several parts: imaginary numbers, product of the square root theorem, Euler's notation, and complex numbers. They're all parts of the imaginary number topic. So let's think about where imaginary numbers come from. Now, you can take the square root of 4 and you get 2. The reason you get 2 is because you're saying what times itself gives you 4. And we know that 2 times 2 gives you 4. And we know the square root of 36 is a perfect square, and we can find the answer is 6 because 6 times 6 gives you 36. However, come down to this one. What is the square root of negative 4? What times itself gives you negative 2? Negative 4. There's no solution. If you did negative 2, my pen out. If you get do negative 2 times negative 2, you're going to get a positive 4. And if you did 2 times 2, you're also going to get a positive 4. Anything in times itself is going to give you a positive number, so there's no way you can take a square root of a negative number. But some guy, Euler, came up with this idea that if we take the square root of a negative number, we can call it an imaginary number. So before we get into that, I'm just going to tell you the answer to this. If you did the square root of negative 4, you're going to get 2i. So we're going to get to that in a minute, how you come about that. Let's start with the product of the square root theorem. At least one positive radicand. It means that one of these has to be positive, the m or the n. If m and n are real numbers and one is a positive number or both are positive numbers, then if you take the square root of m times the square root of n, you get the square root of m times n. Like this one. Square root of 3 times the square root of 5, they're both at least one of them is positive. That's the key. One is a positive number, at least one. Then you just multiply them together. We've done these before, and you get square root of 15. And it's the same thing. You have at least one positive number, so you're going to get the square root of negative 15. That's what we've done before. Here's the little twist to the whole thing. The product of the square root theorem where both radicands are negative. If m and n are both negative real numbers, then the negative is going to come outside. So square root of m times the square root of n is negative square root of mn. So let's just do this first example. These are both positive, so it's going to be the square root of 6. You have a positive and a negative here, so it's going to be the square root of negative 6. Here we have two negatives, so it's going to be negative square root of 6. Check the subtlety out of those. You have to memorize that. If both are negative, it's not going to be the square root of positive 6, or else it would be exactly like this one, and it's not exactly like this one. So you have to put your negative outside. Now, here we go to our imaginary numbers. I is the same thing as the square root of negative 1. So let's look at this example. If I have the square root of negative 13, we can break that into the square root of 13 times the square root of negative 1. Then we can break them into two separate radicals. We have the square root of 13 times the square root of negative 1. The square root of 13 is done, so it's just the square root of 13, and here's the kicker. The square root of negative 1 is always equal to I. Let's try a couple problems. It says use Euler's notation to write Euler's. I think this is Euler's actually. I like to say Euler's because it looks like that, but it's Euler's notation to write these problems. So here we go. Square root of 17. Eventually you'll ditch the second step. We have the square root of negative 1 times the square root of 17. This would be the square root of 17 times the square root of negative 1, and that would be square root of 17i. Just when you do this, make sure you write your I outside of the radical, make sure it's not close enough that it looks like it's inside. And in this book, they always put the I to the right, not to the left. So here's a different one. Square root of 4 times the square root of negative 1. Square root of 4 is 2. The square root of negative 1 is I. That's that. Most people like these. These are a lot more fun than the completing the square. Let's try this one. This is the square root of 3, can't do anything about it. This is the square root of 2 times the square root of negative 1. All I'm doing here is separating the negative 1 out. So it's separating into two different radicals. So now we have a positive and a positive, so that would be the square root of 6. The square root of negative 1 is I. And that's the main thing about imaginary numbers. Let's move on to complex numbers. A complex number is a number that has a real part and an imaginary part. This is our standard form. When they tell you to write it as a complex number, you need to have an A part and a B part, where the A is the real part and BI is the imaginary part. So it might look like something like this, 2 plus 3i. That would be a complex number. If it asked you to write it as a complex number and you didn't have an imaginary part, you would write 2 plus 0i. Now, adding imaginary numbers together, it's the same as you treat them just like variables. So you add the real parts together, you add the imaginary parts together, and they want these to be written as a complex number. So you write your real part first. So we're going to put our 4 minus 2, and we're going to get a 2, and then add your imaginary part. 6i and 3i is 9i. So that's all you have to do. You add your like imaginary parts, like terms. Just treat imaginary numbers as if they're the same. Now this one's a little bit more complicated. First you have to distribute everything. So you get 4 minus 3i, we get rid of our parentheses, plus 6 minus 4i, minus 2 plus 5i. So here, again, the real part goes first. That's your A part. So we have 4 plus 6 is 10, minus 2 is 8. 4, 6, 2. And then add your imaginary part. So we have negative 3, negative 4 is negative 7, plus 5i would be negative 2i. That's that. That's kind of fun, isn't it? This is a rather long lesson, so let's keep going here. Now, square root of negative 1 times the square root of negative 1 is equal to negative 1. The thing you have to know is I squared is equal to negative 1. You could look at it a different way too. We know the square root of negative 1 equals I, right? If we square both sides, this would come out, so it would be negative 1 equals I squared. Now, you have to memorize that. You have to memorize that the square root of negative 1 equals I, and you have to remember that I squared equals negative 1. Check this out. Simplify 2ii minus 3ii plus 2i minus 4 times the square root of negative 4. You have to simplify that. Let's see how many more we have to go. Oh, we're almost done. So this is the same as 2i squared. Does everyone buy that? I times I is I squared. The next one is the same. We don't know what to do with I cubes yet. So we're going to put 3. We have an I squared, and then we still have an I guy left over. Here we have 2i. Here we have minus 4. And let's go even further, apply what we learned earlier in the lesson. This would be the square root of 4 times the square root of negative 1. So hopefully you understand everything so far. I just have to take, if there's multiple i's, like if I have I times I times I times I, you need to break them into their I squared parts. So this would be I squared times I squared, because we know what I squared equals. I squared equals negative 1. So now I'm going to start replacing all the I squareds with negative 1's. So you get 2 times negative 1 minus 3 times negative 1, but the I has to stay, plus 2i, minus 4, minus 2, and square root of negative 1 is I. It's so easy to make dumb mistakes on these. It's like, I think it's the easiest problems to know how to do but get wrong. Alright, carrying on here. So we're going to get, so what I'm saying about that is don't skip steps. So you get negative 2 plus 3i plus 2i minus 4 minus 2i. And the whole time I'm hoping that I get the right answer for this. Now we have our real part. Here's a real guy, here's a real guy. So we get negative 6. The 2i and the negative 2i cancel each other out, they add out, and we get plus 3i. And that is the answer to that problem. Let's try one more, and then you get to try one. Alright, so this time I have 3i cubed. Now, I cubed is equal to I times I times I. So we're going to get 3i squared, and there's still an I left over, 2i squared plus 7i plus 4 plus, this is 2i to the 5th. So let me pull I to the 5th over here for a second. That's the same as I times I times I times I times I. So these two i's make an I squared. These two i's make an I squared. And we still have an I left over. So I'm going to make this one into I squared, I. That's I to the 5th. You break them into your I squared parts. That way you can simplify them. Now we replace all the I squareds with the negative 1. So I squared is negative 1, I, minus 2 times negative 1, plus 7 times I, plus 4, plus 2 times negative 1 times negative 1 times I. Keep simplifying. Negative 3i plus 2 plus 7i plus 4 plus 2i. Negative, negative is positive. And we're almost there. Add the real parts. Let's see. I'm just looking at the answer, and it looks like I don't have the exact answer. Negative 3 minus 2. Okay, it's just because I copied a sign differently than the book. Okay, no problem. So we get 4i. Whoops, did I forget an I? I forgot an I. We have this I, and this I. So we're going to get 4i plus 2i is 6i. And I didn't mean to add the i's first. We get 6 plus 6i. And that is your final answer. Here's the real parts, and then add the imaginary parts. Okay, your turn. Give this one a try. That is a 7 if you can't tell what it is. Turn off the video and see if you can get this. Okay, hopefully you did all that. Let's deal with this one. We have 5. I cubed is the same as I squared times I. 3i squared. This is 7i squared plus 4 plus 2 I squared, I squared, I squared. That takes care of, that takes care of 6, right? If we add those up, it'd be I to the 6, and then we have an odd I left over. Replace all the I squareds with negative 1s. So we get 5, negative 1i, plus 3 times negative 1, plus 7 times negative 1, plus 4, plus 2 times negative 1 times negative 1 times negative 1 times I. Start left to right. Negative 5i minus 3 minus 7 plus 4. Hopefully I didn't lose any i's along the way. Negative, negative, negative is a negative, so it's going to be negative 2i. Now we add our real parts together. These are all real. So negative 10 plus 4 would be negative 6. Add your imaginaries, and you get minus 7i. Always put in the form a plus bi, where the real part goes first, the imaginary part goes second. Alright, finally, that is the end of Lesson 51.